Now, talk about milling methods. Up milling. There are two figures. First one is for up milling. You can see here the feed and cutting, and next one is down milling. There are also feed and cutting, both are same direction, but for up milling, feed and cutting are not same direction. They are opposite direction. Okay, so this is the basic difference between up milling and down milling. Now describe them. Up milling. In up cut milling, the cutter rotates in a direction opposite to the table feed, as illustrated in the following figure. It is conventionally used in most milling operations because the backlash between the lead screw and the nut of the machine table can be eliminated. Next, down milling. In down cut milling, the cutter rotates in the same direction as the table feed, as illustrated in the following figure. This method is also known as climb milling and can only be used on machines equipped with a backlash eliminator or on a CNC milling machine. This method, when properly treated, will require less power in feeding the table and give a better surface finish on the workplace. So this is the basic differences between up milling and down milling, and these are the main two milling methods. Again, I say this: for up milling, the feed and cutting are not same direction, they are opposite direction, and for down milling, the feed and cutting are in the same direction. Now talk about milling operations. At first, peripheral milling. There is a figure of peripheral milling, generally in a plane parallel to the axis of the cutter. Cross-section of the milled surface corresponds to the contour of the cutter. Next, face milling. There is a figure of face milling, generally at right angles to the axis of rotation of the cutter. Milled surface is flat and has no relationship to the contour of the cutter. Combined cutting action of the side and face of the milling cutter. Peripheral milling. Slab milling, slotting, slitting. Slab milling. A milling operation that uses a cylindrical mill on an axis parallel to the work table to create a flat surface. Slotting. A milling operation that cuts a narrow ridge into the surface of a workpiece. Slitting. A rotary tool steel cutting tool with peripheral teeth used in a milling machine to remove material from the workpiece through the relative motion of workpiece and cutter. And there are the figures of slab milling, slotting, and slitting. Next, side milling. Milling with a side milling cutter to machine one vertical surface. Form milling. A milling operation that uses a mill with a unique shape to create that shape into the workpiece. Straddle milling. Face milling of two parallel vertical surfaces of a workpiece simultaneously by using two side milling cutters. And there are the figures of side milling, form milling, and straddle milling. Now talk about face milling. First one, conventional milling. The diameter of the cutter is greater than the work part width so that the cutter overhangs the work on both sides. Partial face milling. The cutter overhangs the work on only one side. End milling. The cutter diameter is less than the work width, so a slot is cut into the part. And there are the figures of conventional milling, partial face milling, and end milling.